Good morning, students. Hope all are doing great and practicing mathematics at home. I do miss you all. Okay, today we are going to discuss about properties of regression coefficient. When I take the class, I request all of you to take down the notes so that it's going to be very easy for you to practice. The first property is the correlation coefficient is the geometric mean between the regression coefficients. What is the correlation coefficient? R. R stands for correlation coefficient, which is equal to square root of product of byx times bxy, which is nothing but geometric mean. Okay, byx is your regression coefficient of y on x. bxy is the regression coefficient of x on y, where r is the correlation coefficient. Okay, this is the relation they have obtained. Okay, students, I just want to show you the proof how they got this value. R is equal to square root of byx times bxy. Okay, here is the proof. Okay, in the previous videos we discussed about the formula for bxy and byx. There is also another formula for byx. Byx is equal to r times, okay, r times sigma y divided by sigma x, where sigma y and sigma x is the standard deviation of x and y variable. Okay, r we know it is the correlation coefficient. In the previous videos we discussed about Carl Pearson's correlation coefficient, Spearman's rank correlation. Yeah, there we used R. Okay, R is your correlation coefficient. Similarly, there is another formula for bxy, which is equal to r times sigma x divided by sigma y. Okay, now we are going to multiply these two regression coefficients. That is byx times bxy, which is equal to, okay, we are going to multiply. What is byx? We have r times, yeah, r times sigma y divided by sigma x multiplied by, what is bxy? R times sigma x divided by sigma y. Correct. We can cancel sigma y, like terms you can cancel. Here also sigma x will get cancelled. So what you have, r into r will give you r square. Correct. Therefore, byx times bxy is equal to r square. Can I bring square to the other side? If square comes to the other side, it will become square root, right? Which implies r is equal to square root of byx times bxy. We got the relation, right? This is the property number 1. We proved it. Okay, this is how they have arrived the result. Okay, r is equal to square root of byx times bxy. Okay, in general you can say it as the correlation coefficient is the geometric mean between the regression coefficients. Understood, students? Now the second important property is correlation coefficient R, the regression coefficients byx, bxy, all three should have the same sign. That is, if correlation coefficient R is positive, the regression coefficient should also be positive. Okay, if R is negative, byx and bxy should be negative. Okay, I'll repeat once again. If R is positive, both should be positive. If R is negative, both the regression coefficients should be negative. In general, all the three should have the same sign. Okay, it could be either negative or positive. When you solve the problem, you will understand much better. In general, you remember correlation coefficient and the regression coefficients, all the three should have the same sign. Okay, students. Then we'll move on to property number 3. Okay, if one of the regression coefficient is greater than 1, then the other must be less than 1. Okay, what do you mean by this? Any idea? Okay, I'll tell you. If one of the regression coefficients, so we know there are two regression coefficients, that is byx and bxy. These are the two regression coefficients. Okay, if one regression coefficient is greater than 1, the other regression coefficient should be less than 1. Okay, why? Because correlation coefficient R lies between -1 to +1. It should satisfy this condition. Okay, so here is a checkpoint. Okay, for the byx and bxy. Okay, if one of the regression coefficient is greater than 1, then the other must be less than 1. The reason is R lies between -1 to +1. Okay, so I'll quickly give you one example. Okay, students, suppose if I'm going to calculate the value of R using the formula square root of byx times bxy. Okay, now we assume, okay, the value of byx we got is 1.1. It is greater than 1, right? Multiplied by, as the condition says, if one is greater than 1, the other should be less than 1. So we can take this as 1.1 multiplied by this, we will take it as 0.4. 0.4. Okay, now when you multiply, it's 0.4. When you multiply, you'll get something around the square root of 0.44, which is 0.66. Finally, you'll get this answer, which is less than 1. It satisfies the condition. Alright, if I'm going to take the other way around, okay, suppose if I'm going to take it as, okay, if I'm going to calculate it as other way around, okay, just a minute. Yeah, here we go. If I'm going to calculate, okay, if I'm going to take R is equal to square root of byx times bxy, which is equal to square root of byx. In place of byx, I'll take the first term is 1.2, all right, which is greater than 1, all right, multiplied by the next regression coefficient. I'll take it as 1.3. So obviously you will be getting something greater than 1, 1.25, which is greater than 1. It is not applicable. Okay, because the value of R should lie between -1 to +1. So the property number 3 says, if one of the regression coefficient is greater than 1, then the other must be less than 1. Understood, students? So these are the 3 important properties you have to remember. The first property is the correlation coefficient is the geometric mean between the regression coefficients. The property number 2 is R, byx, bxy all should have the same sign. Third, if one of the regression coefficient is greater than 1, the other must be less than 1. Okay, students, this is the end of the properties of regression coefficients. Hope you enjoyed the video. what you can do is you can just take the notes in your maths classwork. In my next video, I'll be discussing the problem based on this properties of regression coefficients. Till then, have a great day. Take care. Bye.